Hi everybody, Mr. Rubo here. Today we are looking at 2.8, which is inverse functions. First we'll talk just real quick about what an inverse is. Inverse relation will undo a given relation. Every inverse relation can be found by switching each x and y. So we're going to look at it a few different ways. So we're going to look first tables, then graphically, and then analytically using equations. So this would be numerically, which is using tables. So if our original function is this table here, for the inverse, you literally just switch the x and y. So the first one would be -1, 1, then 2, 3, 0, 4, and 2, 6. Okay, so the original table is a function because each input has exactly one output, right? So you can clearly see 1 goes to -1, 3 goes to 2, 4 goes to 0, and then 6 goes to 2. But however, if you look at the inverse, it is not a function, and your reason where you can see it is you have 2 here twice, and 2 goes to my stylus does not want to work now. Hold on. There we go. 2 goes to 3, but 2 also goes to 6, which means that's not allowed. And so our reason here, and I'm going to just type it because my computer doesn't want to, or my stylus doesn't want to work. The input, so it's not a function because the input x value of 2 has 2 different y values of 3 and 6. And that would be a great explanation on an AP test on why it doesn't work. Okay. All right, so that was with the table. Now let's look graphically, which is, with a picture, if you will. So, well, it's very, very similar to a table. You obviously have an infinite amount of points, but there's usually some key points like this guy right here. So this point would be 4, 3. And what I'm going to do, actually, I'll just figure out all these ones. So 2, 1, this is -1, 2, and then -2, -1. Okay. For the inverse, what I'm going to do is I'm going to switch all of those values and plot them. So 4, 3 is going to be plotted at 3, 4. 2, 1 is now going to be plotted at 1, 2. And as I'm doing this, I'm then going to connect these points in the same fashion, so a straight line. Okay. Then my next key point was -1, 2. So I'm going to go 2, -1. And they were connected in a straight line. And then -2, -1 would become -1, -2. And there we go. So one thing you might remember is this line here ends up being the line of reflection, which is the y equals x line, which we'll talk more about later, but you can hopefully see it. All right, so now, is the original relation a function? And then it's asking us, is the inverse function? So we'll start with the first one. Yes, the original relation is a function since every input has exactly one output. And then for the second question, no, the inverse relation is not a function since the input of 2, really there's more than just 2, but even having it happen once is enough, has two outputs, so 3 and -1. And there you go. There's enough to say why the inverse is not a function. Okay. You don't want to say vertical line test because that's not enough. All right. So then, yeah, and actually this is what I kind of talked about up above, but graphically, the graphs of inverses are symmetric over the line y equals x. Okay, and then our last type of inverses is when we're dealing with our analytical approach, which is when we're dealing with equations. So here, find the inverse of f of x equals 3x minus 7. Just like all the other ones, we're switching x and y. Just a reminder, f of x is the same thing as y. So what I'm going to do, and I can rewrite this if you want. So I will rewrite it so it's y equals 3x minus 7. I'm going to switch those two around. And in general, we don't like to have a function or a equation in terms of y. We want to solve it for y. So that's what I'm going to do. I'm going to add 7 and then divide everything by 3 or multiply by 1/3, however you want to think about this. But I will get 1/3 x plus 7/3, and right there is my function, or is my inverse function. But the one thing is, we usually write inverses, we denote it with a little -1 in the power. So I would actually rewrite this, and this would be clear that it's an inverse. So I would say f to the -1 of x equals 1/3 x plus 7/3. And there you go. Okay, and that's in general how you find inverses, right? You switch the x and y graphically, table, or equations, all the same step, all the same initial step, and then do some other stuff based on what you're dealing with. Okay, well, thanks for watching, and have a good day.